Hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, add number linked list. Okay. So what the problem is saying is we'll be given two linked list. Okay. Representing two positive integers. Okay. And what we want to do is we want to have the resultant list which will represent the sum of these two numbers basically in the respective linked list. Okay. So what the output will be? So it will be another linked list. Okay. And what let's sum. So 5 plus 5 10, we'll have 0 and 1 carry, then 4 plus 4 8 and 9, right? And this will be our resultant linked list. Okay, this will be our resultant linked list. So that's what the problem is asking. Now let's discuss the approach. Okay, so before going to the approach, I'll request you to please subscribe to the channel, like the video, as I'll try to make it very easy for you. Okay, so since we know, right, that we start from the last the addition, right? We start from the last, and being a singly linked list, we cannot go backwards, right? We cannot go backwards. So what we're going to do is we're going to reverse the linked list. Okay, we're going to reverse the linked list. Okay, so how the linked list will look like? For example, we are going to reverse both the linked list for 5 and 4, right? And another will be 5, 4, and 3. Okay. So let's also, along with this, let's also code. Okay. So that you'll understand better. So let me reset this once. Okay. So let's write the reverse function. Let's name it first reverse num1, right? And second reverse num2. Will be num2. Okay. Let's quickly implement the reverse function. Node reverse equal to node, let's call it head. Okay. Then we use two pointers to reverse the linked list. First will be previous equal to null. I won't explain this logic because we have seen this many times, right? Current equal to not equal to null. So till current is not equal to null, we'll keep on looping. We will preserve the next node of the current. Okay. Then what are we going to do? Current dot next equal to previous. Okay. So previous is initially null. Then we will assign current to the previous, and whatever we had stored, right? In the next we will assign back to current. Okay. So current will now point to the next node. Okay. And previous to the first node. Okay. And finally, our previous will be pointing to the new head. Okay. So with this, the linked lists are reversed, right? With this, the linked lists are reversed. Okay. Now what we're going to do? We are going to do addition. Okay, so what we're going to do? We're going to take a carry equal to 0. Okay, this variable, and this is what we'll call it. We are calling it what? First, right? First and second. So, or maybe we can write it like this. So this is the first pointer and this is the second pointer. Okay. Now what we're going to do? We are going to run a while loop, right? We are going to run a while loop. Let me write that code as well. While first is not equal to null, or second is not equal to null, or let's take a carry variable as well. Carry equal to 0. Okay, carry equal to 0. Or, and the third condition is carry, if carry is equal to 1, then keep on going. Okay, so this is a while loop. Now what are we going to do? We're going to extract the data. For example, this particular, right? So we're going to check, is first this is first not null. If it is not null, then take this data. Okay, take this data. For example, now data1 equal to 5. Let me write that code. If first is not equal to null, right? So first I'll show the Java code followed by C++. Okay. If it is not equal to null, first dot data will take, or if it is null, then consider it as 0. Okay. Similarly, for the second list as well. Okay. So second equal to data2, right? So this is data1 and this is data2, right? Data2 equal to 5. Now we're going to take sum. What we're going to do, sum equal to data1 plus data2 plus carry as well. If there was carry, right? If the carry was 1, right? So what we're going to do, it's sum equal to data1 plus data2 plus carry. right? Plus carry, we are going to take. Okay. And we'll take another resultant uh, list as well. Let's call it dummy for now. New node. This is a resultant list, which will have the sum of the two integers. Okay. And we'll take some temp as well. Okay. Dummy equal dummy. So temp equal to dummy. Now what are we going to do? Dummy dot next, we are going to say new node. Okay. Which will be new node will be this sum mod 10 we are going to do. I'll explain this. What we are doing here is now. So we had this dummy. Let's represent like this. This is -1. Dummy is pointing here, right? Dummy is pointing here, and temp is also pointing here, right? Temp is also pointing here. Now what we are saying is temp dot next equal to new node, which will be sum mod 10. So what is sum? For example, data 1 is 5 plus data 2 is 5 plus carry is 0, right? So sum equal to 10, right? Sum equal to 10. But now if you see, right, 5 plus 5, sum was 10. So we want 0 in this linked list and we want 1 as a carry, right? 0 in the linked list. So what are we going to do? Whatever is the sum, we are going to take the mod with 10. Okay. So that we get this particular integer, for example, right? So that we get this particular number. If we do mod 10. So that's what we're doing. New node, sum mod 10, which will be 0. And similarly, we're going to do carry what? Sum carry equal to sum divided by 10. Okay, so sum was 10 divided by 10, carry will be 1. So carry will be 1. You know, right? Carry is 1 here. So carry will be 1. So let's write this as well. Carry equal to sum divided by 10. Okay. So this is it. This is it. So this will, yeah, we need to do one more few things. This is not dummy dot next. This should be temp dot next. Temp dot next. And we want to also move our no pointers ahead, right? First equal to first dot next, second equal to second dot next. Okay. And temp equal to temp dot next as well. So what is temp? For example, so now temp is pointing here, right? And we added a new node, right? We added a new node. So now we need to update temp. Temp will point here. Okay, temp will point here. And the first was here. So first will be here now. First will be here. Second will be here. So second will be here. So we are going to add again. We're going to take data 1. Data 1 will be 4. Data 2 will be 4. And carry will be 1 this time, right? So 4 plus 1. Okay, which will be 9. Which will be 9. Sorry, which will be 9. So that's what in this way, we're going to solve the problem. Okay. Now, there are a few more steps to be solved. So what are we going to do now? Since we have our answer, a resultant list. Okay, a resultant list. So how is our resultant list looking like? It is looking like this. For example, it is looking like this: 0, 9, and 3. This is the resultant list. Okay, this is the resultant. Now we want to reverse it. We want to reverse it. Okay, so we are going to write the code for that. Let's say we take this into answer. Okay, and we call reverse. We will pass dummy dot next. So dummy is what? So for example, so our list was looking like this. Let me write 390, right? So this is the perfect representation. So our list was looking like this, 390, right? So we want to reverse this, right? We want to reverse this. So now dummy is pointing here. Okay, dummy is pointing here. So we want to reverse from this particular node. We want to reverse from this particular node. So that is why we are passing dummy dot next here. Dummy dot next. Okay. So in the answer, now we have 390. Let me now few more cases we need to handle. So now answer will be like this. After reversal 390. Okay. This will be the answer. Okay. But it may be the case that somehow we had uh, some zeros at the start. When can there be zeros? For example, if the list was something like this: 1, 5, okay, 9, and 3. So 8, 5 plus 3, 8, 9 plus 1, uh, 9 plus, or maybe let's call it here. Okay, yeah, 9 plus 1, 9 plus 1 is 10, and here was 1 plus 1 will be 1 plus 1 will be 2. Okay, anyways, so there can be, maybe I'm not able to recall the proper example, but there definitely can be zeros at the start. And we want to remove the zeros, right, from the resultant list. So what we are going to do? What we are going to do? While answer is not equal to null and answer dot data equal to 0, then we'll keep on going next. Okay, till we don't have 0 at the start. And finally, we are going to return answer. Okay, so here, let me compile this. We'll see the C++ code as well. Okay, there are some errors. What is the error here? While illegal start of expression. Second is not. What is the issue? First is not equal to null. Isn't this allowed? Let me compile it. Null point exception 53. Okay, so here we need to check. If first is not equal to null, then only go ahead. And if second is not equal to null, then take the next pointer. Okay, let's compile it. I think it should successfully compile now. Okay, let's submit it. So let's discuss the time complexity as well. It is going to be O of n plus m. Okay, so it is going to be O of n, we can say. Okay, because we are treating the list once. Okay, and and space complexity, if we can say O of 1 it is. But yes, this is, we cannot, we won't consider the space for the resultant list, right? Okay, so this is it. So I'll just request you, please subscribe to the channel, like the video. Let's quickly see the C++ code as well. So here's the C++ code. Not much difference. Okay, I'll just highlight the difference, the main difference. Okay, I'll attach the code in the description section. You can go through that. It's almost the same, whatever we have explained in Java. Okay, only difference here is, so for example, if there were zeros at the start, right? So here what we are doing is, we want to delete in C++, as you know, right? We need to manage a memory on our own. Okay, so that's what we are doing here. So we are taking the answer if that is 0. Okay, we are going to the next node, and then we are deleting that particular node having 0 data. Okay, having 0 data. Okay, so this is the only difference. Okay, so thanks for watching. Please don't forget to subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.